Welcome to Chem Help ASAP. In this video, we will see an extension of the typical addition of HX to alkenes that most students encounter in introductory organic chemistry. The work in this video is reported in a journal called Organic Letters by Professor Jean-Francois Paquin and his student Xavier Bertrand at University Laval in Quebec, Canada. The citation is on the following slide as well as in the video description. At the top of the slide is a typical HX addition reaction onto an alkene. This is a standard Markovnikov addition. In the first step, the acid protonates the alkene to give the more highly substituted carbocation intermediate. The second step involves attack by X-, the halide, onto the carbocation. These reactions are called hydrohalogenations, hence the title of this slide. They work great as long as the addition involves, now on the upper right, HCl, HBr, or HI. Even though fluorine is a halogen, the addition of HF does not work. HF is not a strong acid, so HF alone cannot protonate the alkene to form the carbocation in the first step. That is a limitation in hydrohalogenations. Well, whenever you say something can't be done, then someone is going to try to make it work. That's true for mountain climbers, and it is true for organic chemists as well. Many scientists have developed different reagents that successfully add HF to alkenes in some cases. A recent addition to these researchers is the group of Jean-Francois Paquin at University Laval. His group's new reagent combination is methanesulfonic acid. So here is methanesulfonic acid, often written MsOH, and something called triethylamine in complex with 3 equivalents of HF. So this is called triethylamine trihydrogenfluoride, and it's also called treat. HF. The utility of this reagent combination is the coexistence of an acid, methanesulfonic acid, strong enough to protonate an alkene in the presence of a fluoride source, treat HF, that is nucleophilic enough to attack the carbocation. Like the other research groups who have worked in this area, the Paquin's group method also works best in certain cases. In the cited work, the alkenes reported are all something called methallyl alkenes, like this one that we've shown. With few exceptions, the reaction of these alkenes with methanesulfonic acid and triethylamine trihydrogenfluoride gives the Markovnikov addition product following addition of HF. The yields for these reactions range between about 50 and 75%, which is quite good for this kind of chemistry. Note that methods for incorporating fluorine into molecules are often in demand, especially in drug discovery. Using fluorine in place of hydrogen can dramatically change the behavior of a molecule in the body. In conclusion, hydrohalogenation is learned by essentially all students in organic chemistry, but textbooks tend to avoid the hydrofluorination. The reaction is possible with the correct choice of reagents. If you want to learn more about how the University Laval scientists performed hydrofluorinations, then check out the reference on this slide or in the video description. Please subscribe, like, or leave a comment. Take care.